Hi everyone. In this video I want to be working through some acceleration calculations to try and show good practice in the completion of acceleration calculations. Just show how to do them. Okay, so in our first one here we have Andre was riding his bike along at 4 meters a second when he realized he was going to be late for work. It took him 10 seconds to accelerate up to 9 meters a second. What was his acceleration? So I look at the question and I think to myself, right, what's the important things here? So he's moving along at 4 meters a second. He's going to be late. He takes 10 seconds to accelerate up to 9 meters a second. Okay, so I'm going to list my givens. My initial speed is equal to 4 meters a second. My final speed is going to be equal to 9 meters a second. And the time it takes for this to happen is 10 seconds. Okay, I've got to think to myself, what do I want to find out? It's acceleration that I want to find out, and which equation is going to be best for this? I've got two equations at my disposal, so I'm not being required to actually organise the equation at all. I can just pick one of these. I see that this one has the acceleration here by itself on the left-hand side of the equation. So if I plug everything in, I should get the result that I want for that one. So I will declare my equation. I will show my working. So the final speed is 9 minus the initial speed of 4 over the time, which was 10. 9 minus 4 is 5. 5 divided by 10 is 0.5 meters per second per second. So we've got an acceleration. I listed my givens, I showed my equation, I showed my working, I gave my answer, and I remembered the units. Okay, let's try another one. Bruce decided it was time to leave for school. He hopped into the car and accelerated from the curb at 2 meters a second per second for 13.5 seconds. What was his final speed? So let's see now. I know that his acceleration here is equal to 2 meters per second per second. I know that the time involved is equal to 13.5 seconds. The final speed is the thing that I want to know, but I haven't got his initial speed. It doesn't tell me in the question what his initial speed is, or does it? He hopped in the car, accelerated away from the curb. So I think it's fair to say that his initial speed was most likely 0 meters per second. Erasable pen. 0 meters per second. So now I can find his final speed. Now look at the equations that I have available. These are the tools in my toolbox. Final speed is on the left-hand side of the equation in this one already, so I don't have to rearrange everything. I can just use that one in this. So I say V equals U plus AT. And now I show my working. We've got 0 plus 2 times 13.5. Oh dear. I think I need that erasable pen again. Which equals, well, 13.5 times 2, that's 26 plus 1, 27 meters per second. Okay, just to check my mental math, 27, 2 times 13.5, 27. It's always good to check your mental math. So we've got givens are listed. We've shown the equation we're going to use. I can see my working. I can see my answer and units. I've remembered my BIMDAS, so I've gone for the multiplied, although, quite frankly, there was no issue ever there because it was 0 plus. Okay, let's try another one. Clancy dropped a water balloon from the leaning tower of Gingin and it accelerated downwards at 9.8 metres per second. If it fell for 3 seconds before hitting the ground, what was the velocity just before it hit the ground? Okay, velocity. All right, that one's a vector, so I might need a direction in this question. Okay, here we go. So I might list my givens. We've got an acceleration of 9.8 metres per second. We've got a time of 3 seconds. We want to find out the final velocity, that's what we want to know, but it doesn't say explicitly what the initial velocity was. But wait a second, if I read the question quite carefully, I see that he dropped the balloon. He dropped a water balloon. So he was probably holding the balloon and then released it, which means that its initial velocity would have been 0 metres per second. Okay, so now I need to choose an equation. I'm looking for the final velocity. This equation here has the final velocity on the left-hand side of the equation already, so I don't have to rearrange everything, so I can just use this one. V equals U plus AT. I declare my equation. I show my working, which is 0 plus 9.8 times by 3, and then I can give my answer. 9.8 times by 3, 9.8 times 3 equals 29.4, plus 0 is still 29.4 metres per second. And velocity, it's asked for velocity, which is a vector, so I should probably give a direction down. So I have listed my givens, shown my equation, shown my working, given my answer, shown my units, and I've remembered that it is a vector, so I've given a direction as well. Denise conducted the ticker timer experiment at school with a data logger. The results told her that her cart rolled down the ramp from rest and reached a top speed of 2.7 metres per second. If it did this in 3 seconds, what was the acceleration? Okay, let's see, what have we got here? So it's got a top speed of 2.7 metres per second, that's our final speed. The time is 3 seconds. Her cart rolled down the ramp from rest. So we can see now, we're not falling for any of this business again, we can see it straight away. Our initial speed is 0 metres per second. We've got a top speed of 2.7 metres per second. The time that it took for this to happen was 3 seconds, and we're looking for the acceleration. Okay, the equations we have at our disposal are these ones. We want the acceleration. In this equation here, we've already got the acceleration on the left-hand side of the equation, so we might use that one. That's the one that will probably be the best one for us to use. So we say A equals V minus U over T. So we've shown our equation. We show our working now. We've got 2.7 minus 0 over 3. And now we just have to figure out what the answer is. So we go 2.7 minus 0 is, of course, 2.7 divided by, what did we say it was, the time? 3 seconds divided by 3 equals 0.9. Well, that makes sense. 0.9 metres per second. So we've got givens, we've got an equation, we've got the working, we've got the answer, we've got the units. The acceleration, technically acceleration is a vector, so we probably should say down the ramp to give a direction. Okay, let's try another one. Elizabeth accelerated her car from 54 kilometres an hour to 90 kilometres an hour in 5 seconds as she drove onto the ramp of the freeway, the on-ramp of the freeway. What was her acceleration in meters per second per second? And we've been given a hint, convert everything to meters per second first. Okay, so we're given these values. We've got the initial speed here is something we haven't had before. It's in kilometres an hour, 54 kilometres per hour. So I want to convert that into meters per second. So when I go to convert something into meters per second, if I've got kilometres per hour and I want to go to meters per second, then there's a very simple conversion. If I'm going from kilometres an hour to meters per second, I divide by 3.6. If I'm going from meters per second to kilometres per hour, I times by 3.6. So I'm going to convert these from kilometres an hour to meters per second. So I say, right, okay, fantastic. 54 divided by 3.6 equals 15. How convenient. 15 meters per second. My final velocity for Elizabeth is going to be 90 kilometres an hour, which is, in meters per second, 90 divided by 3.6 equals 25. That's a convenient one as well. 25 meters per second. And of course, we have a time of 5 seconds. Okay, we're looking for the acceleration. So, acceleration equals the change in velocity over time, which equals, in meters per second, 25 subtract 15 over 5, which equals, 25 take 15 is 10 divided by 5, which equals 2 meters per second per second. So we've declared our givens, shown our equation, given our working, given the answer in units. Down the freeway might be a good direction. Freeway, since acceleration technically is a vector. Okay, 6. How long will it take Frank to accelerate his golf buggy from rest, aha, I know what that means, he's not moving, up to 9 meters per second if his maximum acceleration is 1.5 meters per second. Okay, so what do I know? His initial velocity is equal to 0 meters per second. His final velocity is equal to 9 meters per second. And his acceleration is equal to 1.5 meters per second. Okay, so we're going to use an equation. Which one are we going to use? I want time. But in this equation, time is on the right-hand side, not by itself. And in this equation, the time is on the right-hand side, but not by itself. So I'm going to have to rearrange this equation. I'm going to work with this one. Experience tells me to work with this one. So I bring it back up here and I say, okay, great. A equals V minus U over T. Now, I'm going to plug in my values. I'm going to say, right, 1.5 equals V, which was 9, minus 0 over T. So 1.5 equals 9 over T. T equals 9 over 1.5, which equals 9 divided by 1.5, 6 seconds. Now, when I got to this point, I then just jumped to that point because I've done these questions before. But if you haven't done these questions before, that can be a little bit challenging. If I look at it here, I say 1.5 equals 9 divided by something. So 1.5 equals 9 divided by something. So I might say to myself, 1.5, 9 divided by something, so let's see. 9 divided by 1.5 should equal the something. And we end up with 6 seconds. I'll be looking at rearranging equations hopefully soon in another video. And we see here we've got our givens equation, shown our working, given our answer with units.